So our last session, your topic is cloud computing 2020 and beyond, will be presented by one of our coordinator, Dr. Sanjaya Kumar Panda, who is an assistant professor in the Department of Computer Science and Engineering of our institute. He did his PhD from IIT ISM Dhanbad, MTech from NIT Rourkela, and he did his BTech from VSS. He has several international publications. His primary area of interest includes your grid and cloud computing, recommender systems. He got several. He's a IEEE senior member and SCM distinguished speaker. And he is a young and dynamic faculty of our department. So I invite Dr. Panda to deliver his talk.
Thank you very much, Rasmi sir, for my introduction. So good evening to all the participants. Actually, Professor Dr. Sudhir Misra sir is having some urgent meeting for which we have slightly deviated from our program schedule. So one of his talk is actually cancelled. That's why I have allotted myself to this particular session. In this session, I will focus on the cloud computing 2020 and the beyond, the next decade, what the main roadmap of cloud computing that we are going to discuss. Especially the contribution of cloud in the last 1 decade, we are going to see, and how we can do further work using the last decade work we are going to see in this particular presentation. And you can see this presentation is a little bit advanced than whatever Professor Kumar has introduced or Dr. Syam Kumar has introduced. With the prerequisite of these two lectures, I am going to tell you about some of the solutions as well as some of the future perspective of the cloud computing. So you can expect these topics in this particular talk. First, I will tell you about one of the most burning topic in the field of cloud computing, that is called as public cloud computing. So we'll see the roadmap of public cloud computing in various perspectives, especially in the research advisory firm. There is a very popular research advisory firm, Gartner. We are going to see some of the statistics as suggested by Gartner. Then I will tell you about the search query about public cloud computing as per Google, just to know that which country people are accessing this particular word in their Google search query that we are going to discuss. Then I will tell you about why this computing plays a major role in the research and business community. We are going to see a couple of examples which gives us a motivation to work this particular field. Then basically in this talk, I want to introduce various areas of cloud computing. First topic is the resource allocation and task scheduling problem. So this resource allocation and task scheduling problem is not new. Starting from 1970, there are a lot of algorithms exist for the resource allocation and task scheduling algorithm. Although some of the algorithms I will tell you that is used in the grid computing and later point of time that is extended to cloud computing in our academic community. That problem we are going to discuss. Second, I will introduce about energy efficient cloud computing as mentioned by Professor Rajkumar Bhuiya. This is one of the main trend in decade because energy plays a major role. Earlier, people are using the algorithm without major concern of the energy because we are in the beginning phase or innovation phase. But now we are in the peak phase, so we have to concentrate on the energy aspect of the cloud computing. I'll tell you, introduce this topic because tomorrow I will tell more detail about energy efficient cloud computing in one of the talk, in which I'll explain around 4 to 5 algorithms, which will help you to carry out further research. Then from 2015 onwards, now people are talking about the renewable energy because earlier the data center or the computers, everything is running through our, you can say that is through non-renewable energy or fossil fuels are used by the cloud service providers to run the data center. But due to its high impact on our environment, peoples are now developing algorithms based upon the renewable energy. And we'll see the pros and cons of both renewable energy and non-renewable energy, whether renewable energy is going to replace the non-renewable energy or both things are required for the data center that we are going to see. And one of the recent invention you can say in the last couple of years that vehicular ADAS network and cloud computing is merged. These two area has introduced a new thing that is called as our vehicular clouds. So based upon that, we are going to discuss some of the algorithms. And last, in the research topic perspective, we are going to see some of the security, privacy, protection in cloud computing. Although I have not much focused in this particular area, but rest 4 areas I will tell you in more detail. And security, privacy, protection perspective also, I'll tell you about some algorithm, but our group is working in only the first 4 research problems. Then at last, I will tell you some of the advanced technology which replace some existing technology of the cloud computing that we are going to discuss, followed by the conclusion and references. If anybody is interested with respect to each and every research topic, I have mentioned various research articles. Those who are interested to work in one of these 5 research topics of the cloud computing, you can refer these papers. And I want to tell the cloud computing is not limited to these 5 research topics. There are a lot of research areas are there. People are focusing in different aspects, but we are focusing on these 5 topics. So I am going to tell whatever the background study or state of art with respect to these research topics. So let me show the first one that is called as our Gartner Hype Cycle. So this Gartner is a research advisory firm. Gartner releases the Hype Cycle twice in a year, focusing on the information communication technology or focusing on ICT market. Based upon the market demand, it is going to predict that what are the technology that are required for cloud market or ICT market that you can see in this particular Hype Cycle. This Hype Cycle was released in July 2019. You can get the latest cycle, but in general, the Hype Cycle released after 6 months or after 1 year, okay, in the public domain. So here, if you see this Hype Cycle, a couple of technologies are written with different colored dots or triangle. So let us understand what is the meaning of these particular dots. So you can see in the bottom that it is written the plateau of the technology will be reached within these years. If a technology will its plateau is reaching by next 2 years, it is written in the white dots, right? Similarly, other dots are representing, one dot is representing 2 to 5 years, another is representing 5 to 10 years, another is more than 10 years, and a cross mark is indicating the technology is obsolete. So nobody is going to use that technology, or the technology is replaced by our new technology, whatever available in the market. So if you see this particular Hype Cycle, you can see in the top part, there is something written as public cloud computing in GCC. So GCC stands for your Gulf Corporation. That is, as for the Gulf Corporation, it is as for the status given by GCC. The public cloud computing is will be popular in the market for next 10 years. That is, it is more than 10 years, as it is suggesting, right? Similarly, you can see other technology like digital twin is also one of the popular technology for industry 4.0 perspective, or Internet of Things perspective, right? Which is combining both living things and non-living things. Both can be clubbed into same thing, or you can say it is a virtual mirror kind of thing. Whatever things you are doing, machine is going to do the same thing. Whatever instruction you are giving, same instruction is followed by the machines, right? Or by the robot, you can achieve this one. So digital twin has a future of next 5 to 10 years, which requires our Internet of Things is plays a major role for digital twin, or you can say for industrial IoT, digital twin plays a major role. Similarly, you can see a lot of technology, like here you can see one of the popular IoT based technology that is called as IT-OT alignment. That is called as information technology, operational technology alignment. That is nothing but integrating the IT services in the business perspective, right? How you can provide better services using the IT, information technology. In many organizations, starting from the raw material to the final product, people are using services, right? Various IT services to perform the work. That is supported by IT-OT alignment. So it is the plateau is expected to reach in the next 2 to 5 years, right? You can also see Internet of Things is here. It is showing Internet things will be emerging for next 5 to 10 years, right? Similarly, Internet of Things in oil and gas, especially in the oil and gas sectors, it is also predicted to 5 to 10 years. So, couple of technology you can see in the case of Gartner hype cycle. So, it is always suggested in the market perspective to see the latest hype cycle whenever a particular company is planning to switch to cloud, right? Suppose as a CTO of a company or as a CEO company, you have to decide that whether to switch to cloud or not. Then you have to see the Gartner hype cycle, and based upon that, you can decide if there is a future, then you can switch to a particular technology. So as for this GCC, you can see public cloud computing will grow for next 2 to 5 years, but its adoption will take more than 10 years. Why the adoption is taking more than 10 years? Because while we are deciding to move to the cloud or to the particular, we are going to subscribe a particular cloud service provider, so we have a lot of restrictions, right? Our technology may not be compatible with their technology. The way we are thinking to move to the cloud, the actual thing is different. So that requires the skilled infrastructure as a service labor, right? Or the engineer, right? Or the worker. So its adoption is expected more than 10 years as for the Gartner hype cycle released in the July 2019. Now, if you see some of the statement given by many people of Gartner, if you see, they specified that the vice president or analyst of Gartner, his name is G. Petrie, he suggested that by 2023, the leading cloud service providers will have a distributed ATM like presence to serve a subset of their services. Professor Bhuya also specified that the fog computing is nothing but the localized cloud, right? So you can see all the computation need not be sent to the cloud for its efficient processing. Sometimes you require a application which is delay sensitive, right? You have to complete the work within a fraction of a second. So you may get the wide area network connectivity problem, internet problem, whenever you are sending the data to the cloud to process it and get back the result. So that can be done by the local servers or in the fog layer instead of sending all the things to the cloud layer, right? But whenever there is you have time and you have a big processing, then you can switch to cloud in order to do the work. So by 2023, everybody is expecting like we are using ATM in our day-to-day life. Similarly, the ATM is going to provide various services to solve various local problems as suggested by the vice president of Gartner. Similarly, especially he focused on the 4 different trends, which is very much emerging as in 2020. First one is called as cost optimization will drive cloud adoption. Why people are adopting the cloud? Because if you compare the physical infrastructure with the virtual infrastructure, then definitely virtual infrastructure is less costly, right? Suppose I will build for a particular application. I require 30 servers, right? And these 30 servers, if I'll get from a particular cloud service provider, then that is less costly than purchasing 30 server for my organization. Especially nowadays, government is also taking initiative for the startup companies. If you see in the startup company perspective also, we cannot invest much amount in the very beginning phase because we do not know whether our business will run or not, right? Whether we are going to sustain in the market or not, right? But definitely, if cost optimization will be there, then peoples are heading toward the cloud will increase and cloud adoption will also depend upon this cost optimization. So there is also analysis says that as per Gartner, by 2024, nearly all legacy applications migrated to public cloud infrastructure as a service will require optimization to become more. If you see in two perspectives, user perspective, we want to get the service with less cost. If you see the cloud service provider perspective, they want to manage the resources in such a manner that they can accommodate more users, right? If a proper management will not be there, the infrastructure requirement will be drastically increased from the cloud service provider side, and for them also it is not a cost effective solution. So everybody want to manage with the current resources. If I have X resources, I'll see how I can manage all the users or the maximum number of users with that X resources without expanding my infrastructure. So that is the first trend specified by Gartner. Second one is called as your multi-cloud will reduce the vendor lock-in problem. Also, Professor Bhuya has introduced about the vendor lock-in problem, but I will tell you in details. Suppose you are interested in X cloud, okay? You have subscribed X cloud, right? Let's say in 2018, you decided to subscribe a particular cloud and you have subscribed it and you are using it. In 2021, you have seen there is another cloud service provider, Y, which is going to provide you the same service with less cost. So just to see that scenario, we are using the both thing, right? In 2018, you subscribed one, you are continuing, you are using that services till now, but you have seen in a later point of time, let's say in 2021, some new cloud service provider is coming who is giving interesting offers or more reliability or more quality of services to you. So what you can do, you can decide your company as a company CEO or a company chief technical officer, you are going to decide whether to switch to the cloud service provider Y or not, right? So you may take a decision as an administrative point of view, okay, we'll move from one cloud service provider to another cloud service provider because you do not know the technical details of moving from one cloud to another cloud. What is the problem you are going to get? As you are moving from one cloud to another cloud, you may face vendor lock-in problem. The meaning of vendor lock-in problem is that the libraries, the APIs, the standards followed by a particular cloud service provider is different from other cloud service providers. Like the way you are maintaining the record, the way I am maintaining the record is different, right? So whenever we want to migrate, compatibility issue will be there, interoperability issue will be there, right? So you are locked with a particular vendor. Even if you want to switch to a particular cloud service provider who is providing the same service with less cost, with better quality of service, it is practically not possible to move from X to Y. Even if an administrative decision is there, but if you go for the ground reality, it will be very difficult. So it is stated by Gartner that these multi-cloud strategies will reduce the vendor dependency for 2/3 of the organization by 2024. So this dependency or this particular problem is going to be solved in some extent by 2024. So that is also one of the important aspects if you see in the CSP as well as the user perspective. Third one is, suppose my company has decided that we'll move to a particular cloud service provider. Then we should know what are the responsibility our company has what are the responsibility the cloud service provider is going to provide us? You have to very clear, right? Which part you have to take. It is not limited to the performance and availability, but it is also related to various security aspects as well, right? That's why as our infrastructure as a service engineer or skill or labor, right? They are not having sufficient background, so it will be very difficult to move from traditional infrastructure to the cloud infrastructure. So we are expecting by 2022, this inefficient cloud IaaS skills will delay the maximum enterprises, that is more than a half of enterprises migration by at least 2 or more years. So suppose you have decided today, but moving from a traditional to infrastructure will take time because you have not skilled ISS infrastructure as a service engineer or the cloud migrator, right? So this is the third issue as specified by Gartner. Fourth issue, if you see that what we already discussed, it will be a distributed cloud, will support expanded service availability. If it will be available like our distributed APM, definitely the latency will be very less, right? Suppose I want to go to local market to purchase a particular vegetable and I am going to some faraway place to get the vegetable, definitely the local market I will get the vegetable with less time, right? Similarly, if the cloud will be available like a distributed ATM, so the cloud which is near to you, you are going to use it because quality of service matters a lot. They are going to provide is the quality of services irrespective of it is a local service or it is a service provided by the cloud. So with respect to this low latency application, if we are expecting the service availability will increase, also the cloud adoption will also increase, right? So these are the 4 trends impacting the cloud adoption in 2020. Now, if you see the revenue of cloud, if you see Gartner forecast, the revenue of the cloud, if you see the annual revenue is $227.8 billion in 2019, but it is growing 17% by the end of 2020. This is an expectation by cloud, right? That various cloud service providers revenue will increase at least 17% if you see by the end of 2020. So if you see due to this COVID-19, if you see the recent articles also says that the revenue is not going to increase 17%, it is far away from the expectation. Because earlier people are using the services provided by cloud. Those people who require, they are using this cloud, but nobody is habituated with these online platforms. So whatever online platforms we are using, they are hosted in the cloud. Now in the WebEx platform, you know, this recording is also done in the cloud, right? So as the number of users are also increasing due to this COVID-19 pandemic, so we are expecting the revenue of the cloud will definitely increase by the upcoming years. So here if you see, the infrastructure as a service secured the highest growth in 2020 due to data center consolidation. I will tell you about this consolidation term later. So we are expecting that infrastructure is having more growth in comparison to other services, right? Similarly, the research vice president of Gartner, Mr. Sid Nag, specified that at this point of time, cloud adoption is in mainstream. And if you see the forecast period from 2018 to 2022, if you see what kind of services are provided and how much revenue we can expect from each and every services, you can see here cloud provides 3 basic services. One is our infrastructure as a service, IaaS. Another is platform as a service, software as a service, like business process as a service, and cloud management security services. You can see their revenue in the forecast period 2018 to 2022, right? As I mentioned, in 2019, it is $227.8 billion, and it will be increased by 266.4 billion. But if you see the comparison of these services, so you will find the highest value you are getting in the software as a services, but the highest growth we are getting in the case of infrastructure as a service, right? So this is the statistics suggested by the Gartner. Now, if you come to the second motivation, so there is a Google search trend. In Google search trend, if you go to Google search trend, if you type a particular word, then you are going to see that what is the how many search queries are received by Google for that particular keyword. For example, I have searched in the Google search trend the keyword public cloud computing, and here you can restrict your search to a particular country, or you can open your source to all over the world. Similarly, you can also select the last 5 years data or the data from 2004 to present or today. So I have selected the past 5 years just to know that how many search queries are received by public cloud computing regarding this keyword public cloud computing. So if you see, this is the graph you are getting. There is a heavy fluctuation you can see here. And this particular statistics is given out of 100. So this is a relative index. Suppose highest search query is received at this point of time, then it will be calculated as 100 based upon the other days are scaled from 0 to 100. This is just a relative grading. So you can see this is the interest of the public cloud computing from 2015 to 2020. Similarly, you can also see that which country peoples are searching this particular keyword, which country peoples are interested in this particular keyword. You can see India is in the first position. Obviously, the first person's index is 100. Similarly, you can see apart from India, the search query is received from Malaysia, as well as United States, Canada, and United Kingdom. So these are the search queries people are getting related to public cloud computing in the last 5 years. Similarly, you can also see what are the topics and what are the queries people are asking in the Google. If you see, the related topics are coming like capital expenditure, secondary school, para virtualization, on-premises software, enterprise software. Some topics are related and some topics are related to this search query is coming based upon some linkage between the public cloud computing and other topics. Similarly, people are asking some questions like types of cloud computing, what is cloud computing, the committee which designs the standards and regulation, types of cloud computing, that is public cloud computing, private cloud computing, hybrid cloud computing. These are the basic questions people asked in the Google, okay, which makes the public cloud computing search term is increasing. That's why the public cloud computing term is increasing, and they are related to this particular keyword, right? Similarly, in the Indian context, if you are going to see, Andhra Pradesh is in the first position, Tamil Nadu in the second position, Karnataka in the third position, Telangana, Maharashtra is in the fourth and fifth position. So this is only to know the search query received by a particular keyword. So if you type any particular keyword like COVID-19 also you can type, and you can see how, where the search query is, you are getting maximum search query is as per the data given by Google Trends, right? Now let us see why people are interested in this computing. Like today we are talking about cloud computing. Tomorrow maybe fog computing is a more emerging topic. Next, people are also talking about edge computing. Many people are also talking about osmotic computing, right? There's a lot of computings are coming. What is the main motivation of going for this particular computing? I want to tell you with the help of 3 motivational examples. First one, if you refer to a banking system or you refer to a particular institute, let us assume that a particular person is working 7 hours per day, right? If we are going to our institute as a research scholar or as a faculty member or as a student, a system is allotted to us. That system we are using for, let's say, 7 hours per day, right? We are using that system, but maximum cases the value may increase. Just I have taken 7 hours per day. But if you go for the banking system, they are using 7 hours per day. You have taken here, right? So we are assuming that there are 6 working days. 6 working days there. Sundays we are assuming it is a holiday. So if you see how many hours you have used the computer system, you have used the computer system for 42 hours. If you concentrate on a particular week, then we are using 42 hours per week, right? But if you see total hours is 24 into 7, 24 hours per day into 7, so it is 168 hours. So if you calculate, you will get, you are using only 42 hours out of 168 hours, right? Which results, the resource utilization is only 25%, right? Here we are talking about a particular computer system, but people are also talking about the data center, or people are talking about the workstations or servers, right? As you can see here, in this case, the utilization is only 25%, which is not fair, right? The utilization is very low, but we have paid the amount to purchase that particular computer system. Similarly, for any application or a particular organization, if you see, that organization may have thousands or 10,000 of computer system. If all the computer systems are utilized is like 25% or below 25%, that is not fair, right? Or in the server case or in the data center case, if it is low, that is not fair, which enables us to develop the resource management mechanism or scheduling mechanism, so that how we can enhance the utilization of the resources. That is the first concept. Second one is, if you see the IBM study, old study in 2000, IBM stated that the average resource utilization of a personal computers, total personal computers, if you see all over in the world, so it is only 5 to 10%. Rest time the personal computers are not used. So you may have two or three computer systems nowadays, right? So you are using one computer system, and other systems you are not using, right? Similarly, if you see the statistics with respect to the server, then you are getting 30 to 35% time the servers are busy. Rest time they are completely idle. Although it is a quite old calculation, but if you see the organization that are maintaining the traditional infrastructure, this calculation is slightly increased, but true today, right? Those organizations has not migrated to the cloud. Okay, if you analyze their utilization of the resources, then you will get slight change, let's say 10 to 20%, but not more than that. Or in the server case, it is maybe 50%, but not more than that, right? As per the report received from NRDC, right? Which also says that if the resource utilization is not proper, so why we are purchasing so much hardware and computer systems for our application or for our organization? That is the second thing. Third thing, suppose you have subscribed to some newspaper, right? And you inform to that newspaper delivery boy that I need newspaper at morning 8 because I have to go to my institute at 9. So 8 to 9, I want to read the newspaper. And if the newspaper is not delivered before 8 a.m., that will be counted as an absent one, right? So what happened? You have subscribed a particular services, and that services you have put a particular deadline. If somebody is providing within the deadline, then you are going to pay for it, right? Otherwise, you are not going to pay for it, right? So we are not looking into the traffic condition. We are not looking at where the newspaper is coming. We are not looking how it is delivered. We have put a deadline. That deadline is 8 a.m. I need the newspaper. So what we want? We want the services. By if the service is delivered, then we are going to pay for it. If the service is not delivered, then we are not going to pay for it. Okay, which requires also, which gives us the motivation to work in the computing field, right? That or in the cloud computing, we are going to subscribe the services. If the service is delivered with the quality of services, we are going to pay for it. Otherwise, there is a service violation may happen. Or if you are traveling in train, right, from X location to Y location, right? X location to Y location you are traveling, you want to book a particular meal, right? So you go to Comsum website. In the Comsum website, you register with your PNR number and specify the station and order a particular meal, right? So that the meal will be delivered in that particular station. Suppose the train which you are traveling, the train is delayed by, let's say, 2 hours, right? It will reach to the peak point location at after 2 hours. So it is the responsibility of the Comsum to provide the food at that particular station. But if it is not going to provide the food for you, then the service violation happen. So you may claim the refund, or you can also initiate some kind of complaints and feedback, right? So which says that service is very much important. If service will be delivered, then only we are going to provide, we are going to pay for that particular service. Now, with this background, let us see the first research problem, right? The first resource problem is called as resource allocation and task scheduling problem. Although if you go to Google, if you search the research paper related to resource allocation and task scheduling, you will find both terms are synonyms of each other, right? So, but both terms are different from each other, right? Resource allocation is the very first step. Once resource is allocated for your application, then you can perform the second step, that is called as our task scheduling, right? So if you see the first one, okay, first step is our resource allocation. For example, for a particular company, right? Let's say you have a company. In that company, you want to deploy a particular application, right, in the cloud, for which you require, let's say, 30 servers. Okay, you need 30 servers to deploy your application in the cloud. Okay, for these 30 servers, you have specified some requirement. What is the size of each and every server, everything you have mentioned. With the cloud service provider's consultation, you have decided it. So once you have signed the service level agreement, which is a agreement between the cloud service provider and the cloud user, the cloud service provider is going to provide you these 30 servers, 30 virtual servers to you, right? Or 30 virtual computers to you, so that you can deploy your application. So that is the first one, that is called your resource allocation. But once resource is allocated, a particular application may be modularized. It may have multiple modules, right? Or it may have dependency between the modules, right? So based upon that, you decided which server is going to handle which module. For simplicity, I can tell you, for a particular service, a student is a module, right? If you go for academic, faculty is a module, admin is a module, right? So I'll decide which module will handle student, which module is going to handle faculty, which module is going to handle the administration or the other stakeholder of a particular organization, right? So the way you are dividing this work and the way you are executing the works in these 30 systems coins a problem that called as a task scheduling problem, where we are mainly focusing on in which order you are going to process these tasks, right? The work, whatever you have, how you are going to assign these works to the computer machines. That is called as your task scheduling. So with respect to this problem, I have given 12 different baskets, right? So you have to pick one problem. Each and every thing, if you pick from one basket, then you can coin a particular problem. In fact, these problems exist also. For example, you have to choose particular infrastructure as a service. Generally in IS is responsible for this task scheduling kind of thing, or platform as a service, or software as a service. Or a particular a number of clients are requesting for these services, whether it is a infrastructure service or platform or software as a service. If many clients are requesting for the resources, or they want to go ask for the runtime environments, or they want to deploy the applications, so you have to see which application is requested first, which application is requested second, and so on, right? So you have to restrict your things about to a particular infrastructure or software or platform. Similarly, you have to decide whether you want to develop the resource allocation problem in which you are allocating the resources as per the request given by a particular user, or you want to develop the task scheduling algorithm where we are focusing on the ordering of the task. Ordering plays an important role. If a proper order you can manage, then obviously the service which is provided, that will be provided in a better way, right? Or you can increase the efficiency of the system. So if you are going for such problem, the task scheduling problem, there are three different modes you can consider. First mode is called as immediate mode. So immediate mode says the task, whenever a particular request is reached to particular cloud service provider, the cloud service provider is going to solve that particular request. You should not wait, which we call as an online kind of algorithm. You have received a request, you are going to allocate the resource. But sometimes what happens, we have requested a particular resource, but our resource is not required at that particular period of time. For example, I want to use the resources from 9 p.m. onwards, but I have requested to the cloud service provider now. So there is a buffer time is there, right? So at that time, if other users are also submitted such type of application, where they require their service after some time, then we can do some kind of better mapping, for which we are going for the batch mode. So which is sometimes called as your offline scheduling, right? We are keeping everything in the batch and we are doing some matchmaking process. With this matchmaking process, we are going to assign the requests so that better resource management can be achieved. Third one, you can go for mixture of this online and offline algorithms. You have to assume that some task is coming on the fly and some task is required that resources in the later point of time, you can mix it. So you have to choose one of the more. Similarly, whenever we are talking about the task may be independent in nature or the task may be dependent in nature. Independent means one service is independent of another service. Okay? Or it is dependent in nature. Once a particular service is over, you have to send the partial result to another service, then only it can process. So they are dependent in each other, right? So you have to keep in mind whether to deal with independent one or dependent one. Similarly, the nature of arrival, the nature of algorithm, the nature of processing may be static or maybe it may be dynamic, right? Static resources may be there, or you are go on adding the resources whenever it is required. For example, now I have switched on 2 virtual machine which is able to solve some problem, but later point of time I need another 5 machine. Okay, so I will increase the demands as for the requirement of the user, right? Similarly, in these scheduling algorithms, you can see it may be primitive or it may be non-primitive. So in various modes, you are going to submit the request to the cloud service provider. So sometimes what happens, your request is given as less importance, some request is given high importance. I will tell you the resource tool which uses this one, right? So if your request is having low priority, then higher priority can preempt your work and can resume the work once the high priority is over. Okay, obviously the starvation problem may happen due to these priority issues. Next one is, as mentioned by Professor Bhuya also, now people are focusing on heterogeneous. In heterogeneous, what we are assuming, each and every system configuration is different. Like in IoT case, the capability of each and every device is different. The capability of the software configuration is different. The hardware capacity is different. Everything is different. Okay. If they are assumed to be same, for example, if you go to cluster computing, in the cluster computing, we are generally assuming that all the computers are having same hardware capacity and software configuration and connectivity. Just like in our particular lab, we purchased 30 computer systems. All the 30 computer systems are identical in nature. In that case, I will tell all the nodes are homogeneous nodes. They are having same configuration, right? But real life, it is not possible, right? Suppose I will tell you integrate 1 billion system. So it is not possible to get 1 billion systems with the same configuration. So we have to go for heterogeneous machines, right? You may refer one particular link I am giving you, that is BOINC, stands for Berkeley Open Infrastructure for Network Computing. It is by University of California, Berkeley. So this particular platform supports various projects. The projects are related to the climate prediction. The projects are related to the DNA computing, drug development, many earthquake analysis, biology related projects are there. So if you go to that particular platform, the particular platform is not owning a single resource. The particular platform do not have its own resource, but people are contributing their resources and it is integrating the resources to carry out the work, right? So you can see that is a specific grid computing project we are saying. So in which the heterogeneous nodes are joined. So if the resources are coming from various sources or various organizations or various part of the world, so imagine the main threat is that at any point of time there is a resource fluctuation will be there. Sometimes I may join with this BOINC project. Sometimes I may leave from this particular project also, right? So, but in average, if you see, the resources are well managed through this particular platform, right? With the extended deadline, they are going to maintain everything very nicely. Now, if you see the category, you have to decide whether the user submitting this one in high QoS mode or low QoS mode. Just a simple example. one guest came to your home, he is asking about hot water, right? If he is asking about hot water, you cannot serve him cold water, right? If you serve cold water, the quality of service, his requirement you are failed to do. So in that case, we are saying this requirement is failed, or in technical terms, we are saying it is nothing but the quality of service is violated, right? But if a person is coming to your home, he is asking about water. So it is up to you to solve whether it is a hot water or cold water, or you will decide based upon the season, right? That we call as a low quality of service. Low means the quality is not low. It indicates that the user has not specified what is the requirement. So you can go for the default requirement. We are using this word default in our CS domain, right? Or you can take a mixture of high quality of service and low quality of service. For example, tomorrow I will give you a demo on Amazon S3. If you see, Amazon S3 is saying the quality of service for the Amazon S3 is 99.99. Total line is 11.9. That is 99.99. Right? 9 number of nines are there after decimal point. Till now, we have achieved up to this. If you require more than that, then we are sorry, we are not able to provide you the service. Okay, whenever you are submitting your request, if you say my requirement is 100%, so practically it is not possible. You know, efficiency is not 100%, right? In that manner, you have to decide whether to go for high quality of service or low quality of service, or a mixture of high quality of service and low quality of service. So in the scheduling problem also, if you see, especially in scheduling problem, when a particular task you have decided to execute in a particular resources, or you have a list of resources, you are going to decide which resource is well suitable for you. Which resources is well suitable means, for some person, cost is a major factor, for some person, time is a major factor, and some person will say that I need average cost and average time. Okay, so based upon that, you can see whether the metrics, whatever you are forming in between the cloud and task, or task and the cloud, this matrix can be categorized into consistent metrics or semi-consistent metrics or inconsistent metrics. Consistent metrics says that if you are considering a list of resources, out of this list, one particular resources is giving better result in comparison to others, right? One cloud is always better than others, or one machine is better in comparison to others. Such type of metrics is called as consistent metrics. But it is not true, right? There are some applications are there that is OS dependent, right? That will run good in the Linux, but not in the Windows system. So in such a system, you can say it is an inconsistent metrics, where you cannot predict which resource will give you the better result. Like Professor Bhuya also mentioned about the Anek tool. If you go for Anek tool, there are several executors are there. So your manager is going to decide which executor is going to provide you a better result, right? But not necessarily that one of the executor is giving always the better result irrespective of the application or task. So you have to decide whether it is an inconsistent or consistent one. Or a semi-consistent type of matrix also we can see, which says that it is a special type of inconsistent matrix where the part of the matrix is consistent. Means out of the list of resources, if you locate 5 resources, these 5 resources are better. Okay, but other resources are not following any particular sequence. Okay. Sometimes what happens, you can go for this strategy. The strategy says that one task is need to be duplicated. Okay, like Amazon is running a particular Amazon resource in 3 different places. Why we are doing this one? Because it may happen that there may be a hardware failure, or there may be some other failure, or there may be a natural calamity, right? So that it will be affecting that particular place. So we are keeping at least 3 backups as per Amazon, so that even if your data is lost in one place, so you can retrieve it from other places. But if you are keeping your data in various places, you have to keep in your mind the data should be consistent, right? So you may go for duplication with the multiple resources. So what I am doing, I am giving the same work to multiple resources, right? I have decided the same work will be given to 3 different resources, then I will collect the result. Or sometimes we are saying, no, we are going without duplication. Based upon that also, you can segregate various research articles. Now, a very important part in resource allocation, we are using leads. Instead of calling it a task, we are saying leads. In real life also, in the tendering process, we are saying leads. So leads is a formal document which specifies various requirements. The first type of leads is called as your advance reservation. In advance reservation, what happened? If a client decided to submit its work in advance reservation mode, then he has to specify the start time as well as the end time. A specific start time you have to mention, a specific end time is mentioned. For a non-technical example, you can say a particular coach or berth of a particular train from a source to destination station is booked for you in your railway travel. So once you reach to the destination, that particular berth is deallocated from you. It will be allocated to some other person, right? So that is given as highest priority among all other leases. Second one is called as your best effort lease, in which we are mentioning the execution time, but we are not specifying when to start or when to end. Right? It is up to the cloud service provider to provide flexible one. So why you are going for such mode? Because that mode is less costly than the first mode. If you say that I need at this particular time, I need the resources, your requirement is high or your quality of service is high, then you have to pay more. But if there is no specified quality of service, that cloud service provider is going to decide when to solve the request to you or when to solve the resources to you. That is called your best effort mode. Third type of lease is called as immediate mode. Immediate mode means once the resource request is reached to particular cloud service provider, the cloud service provider having two modes. One is either to accept that request or to reject the request. If the sufficient resources is available, it will accept it, but if it is not there, it will reject it. So in fact, if you see, it is more costly than you can say our advance reservation lease, right? But best effort is not costly, right? Similarly, in order to avoid this starvation problem, because if you are saying that I don't have any specific time, your request may be a long wait time, right? Your resource, your request will not be given importance. So in order to avoid that, there is a modification of the best effort lease that is called as deadline sensitive lease. We are not going to specify the start time and end time, but we'll say I need 2 hours. You give 2 hours by tomorrow morning. That is fine for me. Okay, I need a 2-hour computation, but I will not specify this is the start time or this is the end time, but I will give a deadline of 24 hours. Within 24 hours, you have to execute my work for 2 hours. So that is called as a deadline sensitive lease. So there are a lot of leases are there with respect to this resource allocation and task scheduling problem. And obviously, if you are going to develop this algorithm, resource allocation and task scheduling algorithm, you have to keep in your mind a set of performance measure, right? So there is a question that here task is same as process or different. Task is nothing but in operating system context, if you see this is a process, right? Although there is different terminology is there, task, subtask, application, job, but application, they are different. Application is different than job, but here if you see in the OS context, in a broad level, task and process is same, right? I'll tell you about what is the application in the later slides. So in the performance measure means, first performance measure is says, given a set of tasks, you are given with a set of tasks, your objective is to complete all the tasks with minimum time. Suppose I have assigned 5 works to you, you completed this 5 work before 9 p.m. Another provider is there, I asked at what time you will complete, he will say by 8:30 I will complete it. And obviously 8:30 is better than the 9. So that we call as your make span, which is called as your overall completion time. Second one is called as your utilization. Utilization says that how much you are utilizing the allocated resources. Somebody may utilize the resource for 100%, somebody may utilize the resource for 50%. Like that, right? Obviously, higher utilization is always better, right? Or in the resource allocation, you are given with a set of leases, and with respect to these leads, you have to decide how many leases you have accepted, how many leases you have rejected. If you increase the number of lease acceptance, obviously your popularity will increase, your reputation will increase, your client will also feel happy, right? So that factors you have to set in order to compare the performance of your algorithm with your existing algorithm. So where you are going to implement it, you can implement the same thing in Cloud SIM, although I am going to tell you about the cloud analyst tomorrow, right? And you can also use this particular leases, what we discussed, that AR, BE, immediate and deadline sensitive leases are supported by Hygia Open Resource Manager. So you can download Hygia Open Resource Manager. There is some predefined algorithms are there. You can use these predefined algorithms and modify. And if your performance is better in terms of lease acceptance, in terms of lease rejection ratio, definitely your algorithm is better than the other's algorithm. Or if you are not comfortable in Java or the language given in the Hygia, then you can go for MPI programming, right? In which you can create several processors and you can assign the work to different processors, right? And any other language also you can use. And many researchers suggested that language is not a barrier to implement these algorithms, because whatever the task you are taking or whatever the processing time you are taking, that is we are collecting from the log files of the actual cloud service provider or the real cloud service provider. So as you are dealing with the log file, you can implement in C, C++, any other language, or Python, any language you can implement. But it is always suggested to use some simulator which is used in the cloud computing like Cloud SIM. Now you can see this problem is now extended after 2013. This problem is now changed. The problem says that, like yesterday also, one person asked whether to go for the centralized system or to go for distributed system. Both systems are having their own merits and demerits, right? For example, see here what happened. You know that the whatever resources the cloud service provider has, that resource is not infinite. Each and every cloud service provider is having finite number of resources. But why they are claiming on infinite number of resources? The reason is that the sum of the requirement of all the users, if you take at a glance, then the resources that cloud service provider has, it is more than that of that, right? Suppose I will ask one person, give me 1 crore rupees. My maximum requirement is 1 crore. That particular person is having 10 crore. Then definitely my requirement will never be 10 crore. So for me, 10 crore is an unlimited one, because my requirement will satisfy with 1 crore. Similar kind of things you can assume here, right? So someday will come, maybe after 10 years, maybe that multi-cloud collaboration will come into picture, because the resource scarcity will be there, or the type of services provided by different cloud service provider is different, right? Somebody may give 99.99, somebody may give 99.69, right? Or in that context, it is providing better in terms of other parameters, but not in terms of this parameter. So in order to standardize this process, or in order to avoid the peak and fluctuating demand, cloud service providers need to collaborate with each other. So whenever there is a collaboration, definitely standardization plays an important role. Standardization will be there. The way you are signing the service level agreement, that is also important, because every cloud service provider is a different agreement. Like whenever we are installing a particular software, you have a terms and condition. The terms and condition of each and every server is your software is different. So definitely standard and guidelines should be there, for which European Council is doing a lot to integrate multiple cloud service provider into a single engine. So here you can see, for a abstract view, I'm telling, let us assume that these are the cloud service providers, right? There are 4 cloud service providers. They decided to merge into a common platform to provide the services by collaborating each other. That is called as our cloud federation, right? So they have created a portal, common portal. In that portal, any user want to use the cloud services, he has to request to that common portal. Once the request will come to that particular portal, there is a broker. The broker is going to decide which cloud service provider is more appropriate, right? Based upon the requirement, based upon the usage also, it can decide which cloud service provider it is going to assign, right? And if it will decide, how it is going to decide which cloud service provider it will allocate, for that each and every cloud service provider is having a manager server, right? You can see it is a manager server with respect to the cloud service provider. This manager server is responsible for the status. They can collect the status from various nodes, and they will know whether sufficient resources are there, or they will know that whether a resource is in the sleep state, or in the active state, or it is in the switch off mode. Such type of status you can get from the manager server. So by consulting the manager server, the central manager is going to assign the work to a particular cloud service provider. Right? So manager server is plays an important role here. But sometimes what happens? I am not going to for a centralized approach, because centralized approach, suppose this portal is down or this portal is failed, then you cannot connect multiple cloud service provider. That is the demerit we are going to get in the centralized case. So at that case, what happens? If you are finding a solution, distributed approach is a solution, but it is also having some demerits, right? In distributed approach, what will happen? The clouds are interconnected each other through a particular topology, not necessarily the mesh topology, whatever we seen in the computer network. They are connected to each other. The request will reach to a particular cloud service provider, right? And that cloud service provider will check the user requirement. If the user requirement is satisfied, then that cloud service will accept the request and can provide the resources. But sometimes the requirement is not satisfied. So what we will do in that case? That cloud service provider need consultation with other cloud service provider to provide that service. For example, I have requested to the cloud service provider 1, but due to some problem, it is not able to provide. So it has to consult with cloud service provider 2, and cloud service provider is going to fulfill your requirement. But this entire system is designed in such a manner that user thinks that cloud service provider 1 is going to provide the service. Right? User need not bother whether cloud 2 is providing or cloud 1 or cloud 3 is providing. User need the service without violating the security aspect or with satisfying the requirements. Right? So this, for user perspective, this cloud computing or grid computing or cluster computing, whenever you go for the arrangement of the nodes, it is treated as a single system. You want the resources from Amazon. You are using your user interface, your web browser to create an account, and you have specified some requirement or some list of requirements are there in that particular website. You have to click a particular requirement. Based upon that, a particular resource will be created. Right? Suppose micro instance is provided by our Amazon EC2. Macro instances is provided, large instance is provided, X large instance is provided. Based for my requirement, large instance is sufficient. So I may subscribe for the large instance. Right? So that may happen. So for me, whether C1 is providing or C2 is providing, the entire distributed system, parallel distributed system is treated as a single system. Through my computer only I am interfacing. I do not know whether my application is run in 30 servers, 40 servers, I don't know. That is the responsibility of the cloud service provider to provide the same, right? So this is the distributed system, but distributed system, if you go, the clock cycle is very much important because the system is not present in a single location. It is present throughout the world. And if you concentrate on that, the organizations are different. The legislation is different. The security aspect is different. The legacy aspects, legacy application is also different. So many problems are there, right? So you have to deal with that one. And each and every country is having different time zones also, right? Suppose you are dropping one mail to another person, he is receiving the mail in his own time zone. So you have to concentrate on this whenever you are deploying a particular task, which is given to any other cloud service provider instead of your own cloud service provider, right? So this problem may happen. For example, you can see a particular application is submitted to a particular cloud. Cloud means that is nothing but the manager server. Generally, a particular application is represented in the form of a directed acyclic graph, which we have studied in the data structure, right? Where one node is dependent on other node. And we know once, if you see this particular application, once A is completed, then only we can execute B and C. So BC is dependent on A, right? Similarly, you can see D can only be completed once BC is completed, or E is completed. E is going to start if C and D is completed. Okay. The very first one is if an application is submitted to a particular cloud service provider, how you are going to partition that application into small modules or task or job that you have to decide. That is a research problem in cloud, right? So if you have partition, for example, this manager server has decided the task number A and the task number D, or you can say combination of AD is called as a job. If you take multiple tasks into a single unit, we call or sometimes called as a job also. This job is need to be executed in this particular cloud. So each and every cloud service provider is having a queue. In that queue, you are going to put that particular job, right? And suppose you have decided the task number E or the job number E need to be sent to another cloud service provider. So in consultation with their manager server, you are going to assign that particular task to the second manager server of the another cloud, and it will be queued in their queue. So once they execute this particular task, they will return these works to the manager server who is coordinating with other manager server, right? Or the user has submitted the request to one particular cloud service provider. So that cloud service provider is going to consolidate everything and return the result to the user, right? In this way, you can do where the partitioning plays an important role. A lot of algorithms are also there, so I'm not going to that. Assignment is also one problem. How to decide which particular task will be executed in this particular cloud 1 or which task is assigned to cloud 2, that you are going to decide, right? Third one, scheduling is nothing but the ordering, because you are not only the person who is giving the work to that particular cloud, that cloud is also handling some local requests, right? So they have to plan that how they are going to allocate the resources so that all the tasks need to be completed with minimum makers. So this is the problem. Now let us see a small example to clear your idea whatever we have discussed in the research topic 1. So you are given with 3 different applications, right? And each and every individual unit, you can call it a task or a group of tasks. Like I will say A, B, C belongs to one group, then you can say it is a job. So in that context, the task, application, job is different. Or you can decompose this A into A1, A2, A3, which you can call as a subtask, right? So basically we refer by an application. So 3 application is submitted to the cloud and their ID is application 1, application 2 and application 3 respectively, right? And the arrival time of this application to the cloud service provider at the 0 unit of time. This application arrived at 3 unit of time. This application is arrived at 9 unit of time. Now, another requirement is there. This application is submitted in the best effort mode. Best effort mode means low priority, right? We have flexible time. But this application is submitted in the advanced reservation mode. And the third application is submitted in the best effort. Just I have assumed, right? What is the difference? If a particular task of advanced reservation application is asking the resources which is occupied by a best effort application task, then you should preempt it, right? Suppose a B application's task has captured some resources or used some resources or using some resources, right? At that time, a high priority, that is your advanced reservation task, is asking the resource, the same resource, then you have to print the best effort, because best effort is less costly and given as low priority in comparison to advanced reservation. Now, you can see here the first application is having 5 different tasks, second application is having 4 different tasks, third one is having 3 different tasks, right? So, which I have written here in the form of columns, right? And let us assume that you have 3 different cloud service provider. They are integrated each other to provide the services, right? And the manager server of these cloud service provider has calculated the time required to complete a particular task in their cloud. For example, the manager server 1 is going to check the time as 2 in the first cloud, 3 in the second cloud, and 5 in the third cloud. These values are in the time units. Let it be 2 seconds or 2 microseconds, 2 nanosecond or 2 minutes or 2 hours. That is irrespective of that. So there is a question that how can we achieve high data availability in heterogeneous cloud storage system? Okay, I'm coming to that, sir, because this is different than whatever I'm discussing, right? Definitely, that is the storage concept, which is provided by various cloud service providers with their availability. Like I told you, Amazon S3 is providing more reliability. Obviously, I'll tell a simple solution to you. If you increase the number of replica, then the data availability will be more, right? But keeping multiple replica is also very much problem, right? If you keep your data in your computer as well as your external hard disks, so the time you are not updating your data in the external hard disks may cause inconsistent, right? So you have to, if you increase the number of replica, definitely availability will be increased, but it is subjected to some number. Not like I told you in Amazon case, it is 3, right? Okay. So these are the calculation the manager server is doing, right? So manager server finds the time in the respective cloud service there in their cloud, and they found that this much time is required to execute task A, task B, task C, like that task L, right? Where task A and E is belongs to your first cloud, FGI is belongs to your second cloud, and JKL is belongs to your third cloud, right? So there is a predefined algorithms are there that is proposed by various researcher, right? Maybe that is a couple of years back. Okay, after the cloud computing invention, so they suggested the round robin algorithm. The very famous round robin algorithm you have studied in the operating system. What round robin is saying? Round robin is saying, don't look into this particular matrix. You have to simply assign the task to different cloud service provider by following a particular order. For example, first task is assigned to first cloud, second is assigned to second cloud, third is assigned to third cloud, fourth is assigned to first cloud, fifth is assigned to second cloud. Once the application is over, you will again start from the 1, 2, 3 order, right? So I have not seen this particular matrix and I have ordered the task, right? So if you compare this with operating system scheduling, so here you can see each and every cloud service provider is getting equal number of tasks by round robin, right? But the task, suppose I have 3 persons, right? I have assigned 3 number of works to these 3 persons, right? Okay, if these tasks are identical in nature, okay, or homogeneous in nature, so more or less they will take the same time if their efficiency is same, right? But in this case, you can see different clouds is taking different time, right? So if you see in that case, the task, the 3 tasks you have assigned to the first person may take 5 hours, whereas the 3 tasks you have assigned to the second person may take 2 minutes. Because the timing is different, because you are dealing with a heterogeneous infrastructure, not a homogeneous infrastructure, right? So this is about the first algorithm, that is round robin algorithm. Whatever sequence I have written, you can find the sequence here, right? You can find the sequence here. In that way, we are assigning, but the main demerit is that this matrix we are overcoming, right? We are not looking into that matrix. Coming to the second improvement over the round robin algorithm, people say that why we are going for such things when the data is available. So why not assign using some particular observation, right? Or some particular calculation we will do based upon that we are going to assign. So you can also suggest if cloud 1 takes 2 units of time, cloud 2 takes 3 units of time, cloud 3 is taking 5 unit time. Obviously, cloud 1 is taking 1 time, best time among all. So let us assign to that cloud. So you can see I have assigned the first task A to cloud 1. Similarly, in this case, it is 684 in 3 different clouds. Obviously, 4 is the less one, so I am assigning the third cloud. Third case, cloud 2 is minimum among all, so I am assigning to that cloud, and we are following that particular order. So this is called as your list scheduling, where we are observing the time required, the expected time to complete, expected time to execute a particular task in different cloud. Wherever we are getting minimum, that cloud we are selecting to assign the task to that particular cloud, right? So this particular sequence will come if you find the minimum of each and every column in this case, right? So I'm not going through others. You can practice this thing. Now, then there is a question may arises, right? That how to get this particular application? These applications you can see, I can draw any directed acyclic graph, or I can write a code to design a different directed acyclic graph, right? But you can design the graph through a code, or you can take some of the standard real life applications which is used in the BOINC platform and can simulate this thing to say that in order to complete these three applications, I require X time, which is better than others, right? That way you can do. So these are the two algorithms. There are some other measures are there that is also used to check the performance of the system, right? Some other measures also you can calculate with respect to the directed acyclic graph in order to decide which cloud is best for one particular task, right? So these measures are nothing but called as T level. T level stands for top level, or also called as your as soon as possible. So given a directed acyclic graph, a single directed acyclic graph we are considering in this case. Let me draw a single directed acyclic graph to clear your idea, right? Like there are 5 tasks. One is A, another is B, another is C, another is D, another is E. 5 tasks are there. So first one is called as T level. In T level, what we are doing? You have to calculate T level of each and every individual task. If you want to calculate the T level of individual task, how you are going to calculate? Each task is having a computation time, the time required to execute the instruction that are given in that particular task, which is generally called as the computation time, right? So once the computation of a particular task is over, what you have to do? You have to send the partial result to other task, which we call as your communication time. So communication time generally happens between two different tasks. Like you can see, once A is completed, it has to send some partial result, which is required for B, or here also you can see that same result need to be sent to the task number C in order to complete it, right? So what T level is saying? T level is saying you have to consider the task, starting task. Starting task is always A. This is your starting task. TS is always A, and exit task is always your D and as well as E, right? That is the end task, right? So from the starting task, you have to calculate the current task time. For example, you have to calculate the starting task TS to A, TS to B, TS to C, TS to D, TS to E. And you can see for some tasks, you may have multiple paths. You have a path to, if you find a path to E, there may be a path ABE, there may be a path ACE. So you have to calculate the computation time and communication time between these two paths and choose the maximum path to calculate the T level of a particular node, right? For example, let me quickly tell you so that the idea will be clear. I am giving some random value, right? This indicates the time required to complete a particular task. And let's say unit time is required to communicate between the tasks. So if you want to find the T level of the node E, you have to start from the starting task, that is A, and you have to come to E. That is nothing but 2 plus 1 plus 3 plus 1 plus 5. Okay. Similarly, another path is there. You have to calculate 2 plus 1 plus 5 plus 1 plus 5. Out of these two paths, whichever is maximum, definitely you have to choose that path in the T level. Similarly, B level is a performance measure in which you can decide which task need to be scheduled first, where we are calculating from the current task or the given task to the exit task. So in this case, if you want to find the B level of, let's say, task number C, okay, of task C, then you have to calculate task C to the exit task E as well as the task C to the exit task D. But there is no path. So you don't have any solution, don't have any other path. So you have to follow only this particular path. In that also you can decide which task is going to assign after getting the B level of each and every individual task. Similarly, static bottom level is taking the same thing as B level, that is TI to TE, that is the given task to the exit task, but it is not considering the communication time. This is the only difference between B level and static B level. Next one is called the critical path. In software engineering also, while project management we discussed, we know that what is critical path. Critical path is the path between the start task to the end task, and it is the maximum path. Based upon that also, you are going to decide which task need to execute first. Or this particular critical path is also used to calculate ALAP, that is called as late as possible. Once you have calculated this critical path minus the path between the exit task to the given task. You have to see the reverse order. Critical path minus the path between from exit task to your current task you have to calculate. Based upon that value, you are going to assign the task to you, right? So these are the measures are there. If required, you can go through the respective papers, right? So once you have these parameters, once you are ready with your algorithm, what you can do, you have to test your algorithm, whether it is working or not, for which you can generate some directed acyclic graph. For which if you are going for random generation, so you have to specify that number of tasks, you have to specify what is the depth of the directed acyclic graph, you have to mention the width of the directed acyclic graph, range of the communication time and range of the computation time. That you have to do to generate the random directed acyclic graph. But nobody can accept it because you have generated your own and tested it, right? That's why the alternate solution is you have to use the real life workflows used by various researchers. Real life workflow means the workflows which is live in the BOINC project or in the real life project. So I am listing here 5 workflows. One is called as montage. Montage is a workflow which is used in the astronomy project. CyberSec is a workflow which is used in the earthquake science project. Epigenomics is used in the biology. SIPSD is also used in the biology. LIGO is used in the gravitational physics. So these workflows are widely accepted in all over the world because it is real workflows. And if you want to see the structure of these workflows, you can see here the workflow structure of the montage. And if you can see the workflow structure of epigenomics and SIPSD, you can see their level is different. The number of the width of the directed acyclic graph is different. And accordingly, you can generate the computation time of each and every individual node. Communication time between two different nodes is different, right? Similarly, you can generate these directed acyclic graphs, right? Similarly, you can see, you can also search for that LIGO and as well as the third one is nothing but SIPSD I told you. Okay, epigenomics is there, montage is a CyberSec. These are 2 workshops also you can find from Google, right? These structures are there, right? So based upon a particular structure also, you can define a particular algorithm. You can say that our algorithm is performing better in the case of SIPSD, but not in the terms of montage and epigenomics. Because it is complete heterogeneity, so you may get different results with respect to different test bench, right? Now, if you are interested in this particular domain, a lot of algorithms I have listed, starting from the grid computing to the cloud computing, you can use these algorithms. You can go through these research papers. I'm not going to explain it, but if you are interested, you can go through this particular one. Here, Rohit sir asked one question. Let me see. How can I identify the critical path in a disjunctive graph of the solution generated in the constructive phase? Sir, I am not aware of your disjunctive graph. Can you please little bit elaborate about this so that after the end of the lecture we will discuss. Can you please clarify what is the meaning of disjunctive? Disjunctive means there is a disconnection between 2 different graphs. If it is so, then both graphs are independent of each other. You can go in any order. Okay, and each and every directed acyclic graph is having different critical path. Like you can see here, the different directed acyclic graphs are there. Their critical path is different. Another question by Chandra Naik sir that could you solve one workflow problem with Cloud SIM, right? Sir, multi-cloud platform is not supported by Cloud SIM, right? It is mentioned in the Professor Asmo's paper. If you are dealing with a single workflow, then it is possible, but multiple workflow is not possible. But I am not going to go through details of the code. But if you require, we'll share the code with you and you can deal with the primary codes, right? So there are some standard data sets are also there with 512 different tasks, which is going to assign to 16 different machines. 1024 task is assigned to 24 machines, 2048 task with 32 machines and 4096 tasks with 48 machines. These standard data sets are there, which is used in the by Professor Sijal is there in Canada, right? So his group has generated these benchmarks. You can use these benchmarks. These benchmarks is nothing but the log files, right? So they have already generated. You can write a code in C++ in order to check it, right? And if you go through each and every individual data set, in each data set, you have 12 instances. Each and every year, you go for 512 and 16 or 1024 or others, each data set is having 12 instances. And the structure of the data set is U underscore X underscore YY underscore ZZ, where U indicates your uniform distribution is used to generate this data set. Later point of time, researcher claim Y uniform distribution, why not binomial distribution, why not other distribution, which is followed in the probability. So based upon that also, they have generated some other data set. Like 1024 into 1024 into 30, yes, this is 32, right? Sorry, there is a mistake. This is 32. 2048 into 64 and 4096 into 48. No, yes, it is 1024 into 32 actually, not 24, right? So these values are wrong. Second value is wrong. Okay. So this 1024 into 32 data set is coming in two different form. One is developed by Ali et al., which they called as A.1024 into 32, and Brown et al. Also proposed another data set, that is B.1024 into 30, right? But if you see the structure of the data set, it is U underscore X underscore YYZZ, but preliminarily they have applied the uniform distribution, right? And X indicates that the matrix is either consistent matrix or inconsistent matrix or semi-consistent matrix. This YY indicates what is the task heterogeneity, and ZZ indicates the machine heterogeneity. Task heterogeneity means the task may be very large, task may be medium, task may be low. Or ZZ indicates the task may be, a machine may be a very high-end machine or a average machine or a low-end machine. That you can, based upon that, they have designed this data set, right? So this is the end of the topic 1. So if you permit, then I will skip the research topic 2, because we are going to discuss this research topic 2 in tomorrow's class, right? Let us directly go to research topic 3, because I am going to discuss this thing, so I don't want to repeat this. Come to the third one, that is called as renewable energy based cloud computing, right? In renewable energy based cloud computing, before moving to this one, you should know why people are going for renewable energy based cloud computing. Why data center is relying on renewable energy? So there are some motivation I have written there. So if you see one report released by US, which reported that in all over the world, 8.6 million data centers are there. Out of this 8.6 million data center, 3 million data centers are there in the United States. And as mentioned by Professor Bhuya also, the electricity required to run a particular data center is same as the electricity provided to 25,000 householder, but later point of time people are claiming it is 80,000 householder now, right? It is a large number. 80,000 householder require suppose X electricity, that much electricity is required to a single data center. So imagine how much electricity is required. And in each and every data center, you have many number of servers. Like one typical report says that 50,000 to 80,000 servers are there. But it varies, right? With respect to small data center and large data center, this report varies, right? And in order to run these resources, these servers in the data center, you require 25 to 30 megawatts of power, right? In the global data center, in global data center case, 416 terawatts of electricity per year is consumed. Okay, and how you are generating this electricity? This electricity is generated through the non-renewable energy that is called as your fossil fuel, right? Fossil fuel is nothing but our coal or gas or aluminum and petroleum that we are using to generate the electricity. In fact, if you see, United States uses the gas and coal to generate the electricity, right? Maximum electricity is generated. Because in India, we are depending on hydropower, but they are not relying on the hydropower, right? But our hydropower is not that much sufficient to generate the electricity, right? We are depending on the hydropower to generate the electricity, right? So if you see if you are using this coal and gas, right? This coal and gas, whenever we are using for the data center or in home also we are using generator when the electricity is not there, or we are using inverter. By the help of electricity, we are able to get the electricity, right? So the amount of carbon dioxide, the amount of particles, and the heat generated by these data center is definitely harmful to our environment, right? The way we are depending on the ICT devices, if you see, now we have two smartphones, two our laptops, air condition in our home, at least 2-3 air condition is there. Like that, if you see the number of components we are increasing, that is more, right? Which is harmful to our environment. So what is the solution? We have to rely on the renewable energy sources. Like biomass is there, hydropower is there, solar is there, is there. So by using these resources, we can run the data center resources. Like many cloud service provider, like Google and Microsoft, they stated that our data center, some of our data center is fully powered by renewable energy sources. They are running their data center with fully renewable energy sources. But many reports claim that if you people are using the renewable energy sources to run your data center, then why you are not detaching non-renewable energy resources? The solution is that why they are not detaching non-renewable energy resources. The reason is that renewable energy sources is not available round the clock. Suppose today the environment is cloudy, or it is our summer season where we are not getting water, right? If such a scenario or wind is not flowing, the renewable energy sources will not work. Even if we are using battery to take a backup, but that much power is not sufficient to run a data center. That's why what happened? Peoples are not detaching the non-renewable resources to connect their data center from the data center. Like you can see a model proposed by Professor Kumar that these data centers are powered with power grid as well as to the renewable energy sources. Okay, so first we will try to accommodate the request with renewable energy sources. If it is sufficient, then it is fine. If not, we will rely on the battery. If battery is providing the power supply, then that is fine. But if there is a scarcity of renewable energy sources, then we have to move to the non-renewable energy sources to get the requirement. Okay, so that at any point of time, users should not face any problem from the provider side. Because if you are not providing the resources as per requirement, you are violating the quality of service agreement. As per the service level agreement, you have to pay the violation cost. That thing you have to keep in your mind whenever you are developing a particular algorithm. Now, if you are interested in this particular domain, I will tell a very simple task scheduling problem, which was developed by Professor Bhuya, right? And our group is also working in this particular paper. Okay, so if you see here, let us take a 9 different requests, right? 9 different user requests starting from U1 to U9. And each and every request is having 3 requirements. One is the start time of the user request, the number of nodes means how many computer systems you require or how many virtual CPUs you require, and what is the duration you require that resources, right? And initially we assume that the load of the data center is U1, U2, U3. These are the 3 different tasks that is already allotted to the data center in some manner. We assume that. Like you can see, U1 is allocated to the data center. U1 need to start at 1 unit of time. Here the time unit I have written T is equal to 1 to T is equal to 9. So 1 unit of time it has to start, and it will occupy only one node for how much time? 4 unit of time. So T equal to 1, T equal to 2, T equal to 3, T equal to 4. First task is already assigned in some manner. Come to the second one. U2 is assigned in some manner to the data center 1, which require to start at 1 unit of time, require one node for one duration. So you can see U2 is taking here. And you can see there are different colors are there. Like here you can say white color and this color. So that color is having different meaning. What is the meaning? This color indicates that this resource is running using renewable energy. And if it is white, it is running using non-renewable energy. And the cost of using renewable energy is constant, right? Assume that the renewable energy cost is constant. But the cost of non-renewable energy is varies with respect to time. Like you can say at T is equal to 1, if you are using non-renewable resources, it is $0.1. If you are taking T equal to 3, you have to pay $0.3. Here you will get $0.4 like that. Now U3 is assigned to data center 2, and U3 require 1 node for 4 units of time starting from t is equal to 1. So we have assigned U3 here, right? So we have assigned U3. So we assume that these 3 tasks are assigned. Now let us follow a particular case that like U4. Before that, there is a question from Rohit sir that how can I start VM consolidation technique for green cloud computing by efficient power reduction in a momentous research area. Sir, VM consolidation we are going to discuss tomorrow. As a abstract point of view, I will tell you VM is present in 3 different states. VM is present in active state, VM is there in the sleep state or wake up state, or VM is there in the switch up state. And it is assumed that if it is present in the wake up state, within a fraction of time it will be active. So all time the resources are not active, right? The resources which are used by the user that are only active. But few VMs are already in the wake up state, so that immediately we can start the such resources, or in the sleep state, so that we can immediately start that resources. So if you concentrate that I am going to tell you 3 or 4 algorithms in the VM consolidation tomorrow. So how we will decide when to switch on another virtual machine, that depends upon the VM consolidation algorithm, for which Professor Kumar and Professor Albert Jomaya from Australia, they developed so many fundamental models. We are going to discuss, right, that tomorrow. So now you can see, suppose I want to assign U4, okay? So I have to adopt one particular algorithm. One of the algorithm is called as future aware best fit algorithm, right? Future aware best fit algorithm. So in this algorithm, what happened? We are going to decide which data center we are going to assign our task based upon the lowest cost. Wherever I am getting lowest cost, that data center I am going to assign a particular task, right? So there I have 2 possibilities. Let us, in this example, I have 2 data centers, means 2 possibilities. And the start time of U4 is 3. And it will continue for 5 units of time, and it wants 2 different nodes. Node means maybe a virtual machine, right? So you can see I am starting with t is equal to 3. I will continue up to 5 units, that is 3, 4, 5, 6, 7. I will continue up to this. And I am mapping with the data center 1 as well as data center 2. I am assigning, you can see here, I am assigning U4 here, right? I require 2 different nodes. So whenever there is availability is there, so I am assigning to first node and second node, otherwise I am going for third node. Similarly, I have assigned U4 into second data center. Now I am going to calculate the cost. While calculating the cost, let us assume that the renewable energy cost is 0, right? Assume that, right? You can take 0.1 also, right? Generally it is a fixed cost. So you can see here, this U4, okay, at t is equal to 3, this slot is your renewable energy slot, right? But this slot is not renewable energy, this is running by non-renewable energy. Similarly, you can see both nodes are running in renewable energy. Here both nodes are running in renewable energy. Here one node is running renewable energy, one node is running in non-renewable energy. And in the last case, both are running in the renewable energy. So what is the cost of non-renewable energy in this case? 0.3. What is the cost of non-renewable energy here? 0.2. So the total cost the user has to pay if it is executed in the data center 1, that is 0.5. That is 0.3 plus 0.2. But in the similar fashion, I am going to assign to the data center 2. Then you can see here you are using non-renewable energy. Here you are using non-renewable energy. If you calculate the cost is 0.3. And here the cost is 0.3 per node. That's why 2 times 0.3. So the cost is 0.9. So as the future aware best bit algorithm says, you have to dispatch the task based upon the lowest cost. Lowest cost means that is nothing but 0.5 is the lowest cost. Then I am going to assign to data center 1 instead of data center 2. So in this fashion, you have to execute the task. So if you are interested in these particular research topics, couple of algorithms are there. You can follow these algorithms, or you can go through my Google Scholar. Recently, we published 3 articles in top level conferences. You can follow that articles also, right? There is a question about Rohit sir. Sir, how can we find the lowest cost, sir? Sir, lowest cost is nothing but the cost the user is going to pay to the cloud service provider, and that cost is calculated based upon the renewable energy resources. You are using renewable energy resources or non-renewable energy resources. In this example, I consider non-renewable energy is the cost is like this, right? That is a dynamic pricing you are applying, just like our IRCTC premium Tatkal scheme. And if it is renewable energy, there is a fixed cost, but this, for the sake of illustration, I have taken the cost as 0, right? In that way, you can calculate the cost, and this cost will be decided by cloud service provider, and it should be signed in the service level agreement whenever the service will be provided. So that user is also aware that dynamic price is applied, right? So couple of algorithms are there. You can follow these algorithms if you are interested in this field. Fourth one is the vehicular cloud computing. In fact, Dr. Rasmi are also working in this particular field, and couple of research articles are also published by our department. You can go through it. So here you can see the cloud computing. The data center is generally present in a particular location, right? But in 2012 and 13, there is a movable data center concept is also coming. Just like you need catering for a marriage party, so you are calling a service, and they are delivering the service. Once the marriage party is over, their job is over. So similarly, the data center may also reach to a particular user if it is required. If the user is required such big power, then the data center is maintained in such a manner that it can reach to the cloud service, to the user end also. Simply, it is called as the queue structure. We are maintaining the queue structure inside the data center, and they are loaded into the truck. Sometimes multiple trucks are reaching to a particular location. They are connected each other to provide the services to the user. Such concepts are also there in the cloud. You can refer to the book if required, right? So here what happens, such concept we are using in terms of vehicle. So here we are merging two different areas. One is cloud computing with vehicular ad hoc network. The problem with vehicular ad hoc network is that the vehicles which is participating in your network, their speed is very high, right? But instead of if we go for wireless sensor network or mobile ad hoc network, we assume that the nodes are either static or the movement is very slow. But vehicular ad hoc network, we assume that the nodes are moving very fast, right? So the main motivation of why people are looking for vehicular cloud computing is that here there are our vehicles. Today we call these vehicles are called as smart vehicles, because these, by the integrating IoT technology or by the applying AI ML technology, these vehicles are now smarter, right? In comparison to earlier vehicles. And each and every vehicle is having an onboard unit, which we call as OBU in short, right? And this OBU consists of GPS, various sensors, radar devices, cameras, digital map, processing unit, storage unit. Many resources are there. But you will surprise that maximum cars are not used, right? For example, I parked my vehicle outside my home, then it is not used. Or if you concentrate on parking lot, or you concentrate on a railway parking lot or airport parking lot, lot of vehicles are there without using that vehicle. The vehicle is parked in that particular place, where each and every vehicle is having some smart equipments. So the concept says that why not the user will also contribute the resources, whatever there in the vehicle, they will also contribute the vehicles, whatever available in the parking lots or streets or roadways or in the parking area of a shopping mall or in the railway station or in the airport. So if they want, they can share the resources. So by using their resources also, you can form a cloud, right? Because their resources are maximum time underutilized, which emerges a new concept in 2014. The first paper you can see by Professor Bhuya, there is a very good survey paper, which emerges the concept of vehicular clouds. And these clouds will be formed and vanish whenever the requirement will be over, right? Means dynamically you can create the cloud and you can destroy the cloud as well. For example, if you compare this cloud computing, vehicular cloud computing is providing more features, because mobility is not there in the cloud computing. They are placed in a particular location, but vehicular cloud computing is movable. Like vehicles are movable from one location to another location. While they are moving also, they can share the resources, right? So cloud formation, autonomous cloud formation is not there in cloud computing, but here you can form the cloud, or you can, whenever it is not required, you can destroy the cloud also. And automatic cloud federation is not supported by cloud computing. Integration with various clouds are not that much emerging in cloud computing, but using vehicular cloud computing, you can do it, right? Next one is moving network pool, right? Your pool of resources are moving at the same time. Like a lot of vehicles are moving in the roads. If they will give the consent also, we can collect their resources, and RSU, the roadside units, can take a decision that which task will be assigned to which cloud, right? That things you can see, right? Like that you can differentiate the cloud computing with vehicular cloud computing, right? So here you can see a particular area or a particular city is divided into various regions, right? You can see I have divided a particular area into 4 different regions, and these regions are also heterogeneous. They are not similar to each other, right? And you can see there are some parking slots are there here. So here the vehicles are parked, and some vehicles are moving from one location to another locations. And you have also traffic light, right? Through which you can estimate how much time a vehicle can stay in a particular grid. So based upon that, these RSU can assign the task or can achieve some amount of work from these vehicles. Using these vehicles, it can do it, right? So it has some vehicles resources which is present in the parking lot, and some vehicles that are dynamic vehicles also, it can use their resources, right? So user can submit their request to the cloud, and cloud can propagate this request to the various roadside units, and these roadside units may coordinate with each other, or these roadside units can be assigned with some work. Based upon that, the work can be deployed in these vehicles by creating the virtual machines, right? Each and every vehicle can be treated as a virtual machine to compute some work in the vehicular cloud computing, right? So you can see a complete structure of a vehicular cloud computing. If you are dividing in the form of grid, you may know that what is the range of the RSU. Based upon that, you can decide that what is the value, what is the size of that particular grid, right? Because if you know the size of the grid and speed of the vehicle, you tentatively calculate that how much time a vehicle can stay in a particular grid. If you know a vehicle will be there in your grid for 10 minutes, or it will be there in the parking lot, then accordingly you can assign the work to that vehicle, right? So based upon that, this area is there. If you are interested in this particular domain, or sometimes this is a latest work done by one of my research scholar, in which we are observing a particular pattern, the pattern of the vehicle flow. Like you know that there are many state transport services are there. Their path is already fixed, right? They will start from beginning of the city, they will reach to the end of the city, right? Their pattern is fixed. At what time they will go, at what time they will come. So there is a tentative value is there. Based upon that, you can do calculation in order to treat these vehicles resources as a virtual machines. So if you are interested in this particular domain, you can follow these algorithms, which is developed by various researchers, and start working in this particular domain. Okay. The last one, what I want to discuss, that are the security and privacy aspects of the cloud computing, right? So there is a question by one of the participants that how a vehicle compute the task if it stands at a parking lot, at the park, right? How the vehicle compute the task, right? The vehicle has to agree that has to give the consent. The vehicle is going to give the consent to the RSUs or ultimately to the cloud service provider that it is going to provide the resources, right? If it is willing to give the resources, then only you can use the resources, and by looking into the capacity of the resources, you can decide what type of work can be assigned to that particular virtual machine. In fact, if you see such type of scheduling algorithm, one vehicle is not computing a complete work, right? One particular vehicle may not complete the 100% work of a particular task. So how the task will be completed? It is done by the migration of the task from one vehicle to another vehicle. So by taking the resources of multiple vehicles in different instance of time, we can able to complete a particular task. In that way, we are calculating, and calculation is depend upon the hardware capacity, the processing power, and the set of instructions you are going to assign to that particular cloud, or the work where you are going to assign. Based upon that, we are calculating, right? The next one is the security privacy aspect. You know, security is providing safeguarding your data, but privacy focus that user identity should not be revealed at any cost. But many people are writing the research articles, and they are indicating that security in the cloud computing is not in an advanced stage, okay, or it is in the beginning phase only. What is the reason? Let us take a non-technical example through which I want to explain. Suppose I will tell you, for you want to travel through a particular vehicle from, let's say, Hyderabad to Delhi, right? So there is a long distance, right? You want to travel, right? So if you want to travel, I will tell you within, you have to travel Hyderabad to Delhi, some kilometer is there, but you have to reach Delhi within 15 hours, right? That is your one deadline I have fixed. 15 hours, within 50 hours, you have to reach to Delhi, right? So if you see in this case, if you assume that, let's say there are 50 check gates are there in between Hyderabad to Delhi. These check gates are nothing but the security privacy policies you are enforcing to secure your data, or to safeguard your user identity, right? So it will be not be possible for a particular person if there are 50 check gates are there or toll gates are there. So you have to stay in each and every toll gate, and you have to pay the fee, you have to maintain the queue, then only you can cross that particular toll gate, right? So it will definitely impact the time required to reach from one place to another place, right? So what is the solution? I'm not saying you have to compromise with security and privacy. Another side, I'm also saying it should not affect the performance. That's why there is a trade-off. The trade-off says that you have to take the two things into concern, that is security privacy should not be compromised. At that same time, the performance of the user application should not be compromised. Both types you have to balance, right? That's why many cloud service provider is now providing single sign-on facility. Once you sign in in a particular cloud service provider, you can move from one domain to another domain without any login, right? There is a single sign, right? So here you can see in the bottom layer, as mentioned by Professor Dr. Sam Kumar, that bottom layer is generally the hardware layer, and the top layers are nothing but our software layers, right? Application layer is software layer, physical layer is your hardware layer, right? So based upon that, you know that infrastructure as a service is available in the bottom layer, and platform as a service is in the intermediate layer, which is providing you runtime environment, and middleware is coming in this picture, which is hiding the complexity of the environment. And another one is your, this is software as a service, which provide you the application support, right? So with respect to this layer, with respect to the deployment, whether you are going for public cloud, private cloud, community cloud, hybrid cloud, or virtual private cloud, the security policies may vary from each other. Like you can see, there is some security policies are enforced to software as a service, and infrastructure as a service, storage as a service, and network as a service. The approaches may be different, right? And you have to keep in your mind the security requirements, that is confidentiality, integrity, availability, access control. These requirements, whether this should be provided by your service provider or that should be ensured by the cloud service cloud user, that you have to ensure before getting a service from the cloud service provider, right? Now, if you are interested in this particular domain, a lot of algorithms are there. I'll tell one algorithm in this list due to time constraint. One is called as your attribute-based encryption. Attribute-based encryption says that we are not going to convert the plain text to ciphertext for each and every data, right? That we will do. But user can claim something by claiming the ciphertext of a particular attribute. Like if you have maintained a particular database, you have a lot of attributes, right? But the encryption and decryption will be done for all the attributes, right? But user will claim this is my data by claiming the ciphertext of a particular attribute. Suppose date of birth is an attribute, the ciphertext of date of birth is generated by looking into the date of birth, or by I want to claim that this is my data, or I want to retrieve the data, I have to use a particular attribute. For this, we are using this particular process. We are using a trusted authority or a certification authority, which is used in the traditional algorithm like Kerberos, and which is generating a public and private key pair. And user is claiming, in addition to this key, user is claiming his data by claiming the ciphertext, not the plain text, right? So this based upon that, some algorithms are developed, right? Now, apart from this, there are some advanced technologies are coming into picture. Already few speakers also discussed this one. Now, people are talking about the Docker and container. Or Dr. Syam Kumar also described about the virtual machine, virtualization technique. So you can see this particular difference between these two diagrams so that the idea will be more clear. So you can see on top of the infrastructure, we are creating the hypervisor. The hypervisor may be your K virtual machine, KVM, it may be XCN, or it may be VMware, the very popular one, VMware. So by installing this hypervisor, what you can do, you can create multiple guest operating system on top of the hypervisor. And the role of hypervisor is to create the virtual machine and monitor these virtual machines. Okay, and there is a guest operating system in each and every machine, and on top of the guest operating system, that guest operating system supports some libraries or bins. On top of that, you are creating various services through creating the virtual machine, right? By creating virtual machines, you are getting various services. So what you can see here, multiple services are using the same operating system, and multiple services are using the same libraries. That concept is now changed by introducing a new concept that is called as container. Okay, and the role of hypervisor is replaced by the Docker, right? So Docker is a containerization platform. Why it is developed? Because whenever you are getting the services, each and every services libraries or APIs are different, right? One service API is different from another service API, right? That's why I told you, whenever you are moving from one CSP to another CSP, you may face the vendor lock-in problem, right? So what this whenever the developer is developing the codes, so they are doing the local development. But whenever they want to migrate to the cloud, they will fail because the operating system dependency, library dependency, API dependency, all are different. So container is going to provide a platform or providing the isolation in which you can run such type of services, right? At a time you can do it. So there is a question by Chandran Naik sir that which tools are used to commonly for the implementation of these algorithms. So which algorithm you are talking? If you are talking about security algorithm, many tools are also there, right? Or which algorithm you are specifying? Here I am not telling any algorithm. Here I am telling about a concept, advanced technology concept. Okay. So if you see, the 66% of the enterprises are adopted the container because container is doing the kernel level operation, right? And the very famous one is your Kubernetes. Kubernetes is a open source container orchestration system for automating the computer application deployment or scaling and management. That's why Google Kubernetes is adopted by 60% of the people. Some of the advanced technology incorporated by cloud, that is called a serverless computing. Like if you are not sure about how many resources you require, you can go for serverless computing in which you have more scalability or more flexibility, right? And nowadays people are going for the microservices, right, instead of the monolithic services, because monolithic services is pointing to a single unit, but microservices is providing by binding various units, right? And DevOps is a new technology that is used for integration of various services, right? For that we are using DevOps, and the integration of IoT, AI, machine learning, blockchain is integrated with cloud computing in order to provide various services, right? So this is the conclusion for today. that we discussed about why public cloud computing is important, what is the life period of public cloud computing with respect to the growth, with respect to its adoption. And as for the Gartner, it is in the mainstream. We also discussed about 4 out of 5 research topic, that is resource allocation task scheduling problem, renewable energy based problem, vehicular cloud computing, and a little bit about the security privacy aspect of cloud computing, right? And also some of the advanced technology like Docker, container, serverless computing, microservices, and DevOps, and integration of various technologies also nowadays done. Based upon that, also various research articles are there, right? And these are the some future topics are there. If you are interested, you can go through this topic. Okay. So we will conclude here. If you have any questions, you can ask me.